raise your hands. No first timer? All? Okay, everyone knows everyone, that's also great. But we have nowadays around like 1,900 members in the CNCF Meetup group, which is quite nice. We follow the CNCF and Linux Foundation Code of Conduct, which in short is that be nice and respectful to each other and include everybody. You can join the community with any of these ways here. We have our Slack channel in the Cloud Native Nordics, Kubernetes Fin in X, and our YouTube channel, Cloud Native Nordics. So reach out to any of these and find us there. We're always looking for speakers. Please come and have a talk if you have a topic relevant to any CNCF project or Kubernetes in mind. And if you want to send us a topic, if you have something in mind, use this QR code or this link here, or even you can reach out to me or other organizers in LinkedIn. By the way, we don't have the other organizers sadly here, but we are a group of people. Unfortunately, Lucas, Gergely, and Erno are not here today for different reasons, but reach out to any of us and talk with us. And also we are always looking for hosts. So our host today is AWS, and we are always searching for other hosts for the next meetups as well. What is CNCF? It was founded in 2015, and it hosts different critical projects which are all building the global technology infrastructure. It's not just about Kubernetes, it's about also other CNCF projects that they build, they maintain. And it brings together the world's top developers, end users, and vendors, and also runs the largest open source conferences. A few words about CNCF project maturity. There are 3 categories if we are talking about maturity level of the CNCF projects. Starting with the sandbox. This is about those projects which are just started, they are in their early stage, and maybe you can start using them and on dev and test environments, perhaps not yet on production. You can even collaborate on these sort of projects. If you want to start somewhere, these are also a good place to find issues, contribute to the project, things like that. The next stage is incubating, and the projects which get a bit more mature and are more stable reach to this stage, and then finally they go to graduated stage. Here we can see a list of graduated projects, for example, Argo, Cilium, which we will have a talk about, Keda, Linkerd, and of course Kubernetes itself. Incubating projects, you can see all this list in the CNCF landscape, and you can also find some familiar projects here as well. Perhaps cross-plane package stage are relevant to platform engineering, Cert Manager, Knative, and then plenty of sandbox projects that just started being part of CNCF and so on.
Question about those.
Yeah.
Is there box also for abandoned projects?
Abandoned?
Yes. Because some development for some of those might have not been going on for some time, and therefore should they be in the list or should they be?
I don't think there is such a list. I
think there is. There is actually. I saw. Maybe you can filter by some abandoned projects or so on. I remember seeing some with abandoned projects.
It would be interesting, to check in the CNCF landscape if there is such filter. I myself haven't seen it. It makes sense that if it's like not, but yeah, you're right. Like it would be nice to see what projects haven't like even entered the sandbox stage. But yeah, CNCF structure, it is built of three main blocks. Governing board, which is mainly about vendors, funding the organization and marketing and strategic direction. Then we have the technical oversight committee, which are basically the architects who decide about the directions that projects in CNCF. Kubernetes administrator. Well, basically it starts from KCNA, like Kubernetes and Cloud Native Associate exam, which is the basic level. If you want to start from somewhere, that would be the very basic one. But when it comes to practical hands-on experience, then the CKA would be the first one that you can start learning and taking the exam. There is also application developer, security specialist, and security associate exams. Yeah, you can see a list of all the training and certificates that they have. By the way, it's not just about Kubernetes. They also have things about other CNCF projects, Arora, for example, Meetups, service missions, I guess, yeah, things like that. There are other different ways that you can collaborate and be in the community. You can become an ambassador. There is mentorship program which you can apply and take part in a mentorship program during some months. You can apply in the CNCF website. There are cloud native community groups which build these local communities and also KCDs. And KCD is basically the next one, like Kubernetes Community Days, that is a smaller scope of KubeCon, and KubeCon is happening once a year in EU and US, and nowadays I guess China and India as well. And this KCD is a smaller scope of this sort of conferences, which is happening in different cities, different countries, once a while, like once a year. And then the next one is KubeCon, which I just talked about. And talking about KubeCon, the next one is in Salt Lake City, Utah, November. If you want to participate, you can buy a ticket. I think early birds are all already finished, but you can always get a ticket and participate there. And these are like some of the KCDs. If you also go to the CNCF website, you will see a list of upcoming KCDs that you can also participate. You can even submit talks if you have some ideas in mind. And finally, you can reach out to us using these different methods that you will find in the slides. Thank you, and now I will invite our hosts from AWS to first introduce themselves and then start their talk.
Can you hear me? No. Let's see. Maybe now. Yeah, okay. Okay, thank you so much, Mariam. So, my name is Sanjoli Arora. I'm a solution architect. Working with AWS for almost now 2 years, and before joining AWS, I worked for CGI for almost 2.5 years, and that is where my journey with Kubernetes started. And we worked on a project where we have to deploy Elasticsearch, open distro on top of Kubernetes. So that is the reason I started learning about Kubernetes, and now it's going on that journey. And today's our topic is Karpenter, and there will be some mention about AWS services, just to explain how Karpenter works with different cloud vendors. So there will be a reference of AWS in my slides, just to be let you know beforehand. So there will be a presentation from my side, and then there will be a demo from my colleague Chakkree afterwards. So let's start. First things first, what is Karpenter? So Karpenter is an open source, flexible and high performance Kubernetes cluster autoscaler. So it helps you to improve your application availability and cluster efficiency by rapidly launching right sized of compute resources in response to changing application load. The next thing is how Karpenter works, in real life. So how Karpenter scales from one compute instance to multiple compute instances. So in order to better understand that, let's see how Karpenter works under the hood. So when we talk about different autoscalers, Karpenter works a bit different as compared to them. So if we talk about other cluster autoscalers, what they do is they will scale out based on the demand. So they will add or they will remove the nodes based on the demands. Whereas if we talk about Karpenter, it will add a node or it will remove a node based on your application requirements. So what it does is it will all the time monitor your pod requirements, and then based on that, it will add a node if required. And other difference between other autoscalers and Karpenter is that Karpenter interacts directly with EC2 API. So what is the benefit of that is that it will provide near just-in-time scaling as compared to another autoscalers. And then Karpenter uses two things. The first one is node pool. So this is a custom Kubernetes resource that is provisioner. So what it will do is it will define what kind of resources the Karpenter will provision. And the second thing is the node template. So it is just like a blueprint which will define what will be the underlying infrastructure and what are their settings, different settings for that infrastructure. Moving forward, so Karpenter, it doesn't do only scaling. So there are some other benefits of using Karpenter. The first one is cost optimization. So by optimizing your resource utilization, Karpenter reduces the number of nodes that is required by your application. So in return, it reduces your cost also. And it also gives, I would say, a user to define some rules, so that the rules based on what will be the CPU requirement, what will be the memory requirement by your application, and based on that, the node which are underutilized will scale down. So in return, that will also reduce the cost. The next thing is Karpenter is best suited for cluster with workloads that encounter a high spiky demand, and that requires a diverse set of workloads. For example, AI/ML also. So if your workloads require that, so Karpenter supports that kind of nodes also. And the last thing is Karpenter do have a feature called Karpenter Drift, via which it will automatically upgrade and it will automatically patch your nodes and your AMIs. So AMI stands for Amazon Machine Images, which are running on your nodes. And then the next thing is where the pod will go on a node. So by default, Kubernetes places the pods across available nodes in the cluster. However, there are some requirements or there are some use cases where you want that a particular pod should go on a particular node, based on maybe that particular node is in some region, or that particular node is in some availability zone, or that particular node has some hardware fulfillment, for example GPUs, or that particular node is running on a Graviton processor. So if that's the case, so that particular pod will go on that particular node. But there are some other use cases where you don't want a pod to be scheduled on a particular node, because of maybe that particular node is running some workloads which you want to isolate from other pods. And then there are the standard Kubernetes pod scheduling mechanism. The first one is node selector. So what this node selector will do is it will allow a pod to be scheduled only on the nodes that have a label identical to what label you have defined in your node selector. And the next one is node affinity. So node affinity provides a fine-grained control over pod placement on the node, and it will allow you to add multiple labels instead of one. You can add multiple labels in pod affinity. And then there are taints and tolerations. So what taint do is it will allow a node to repel a set of pods, and then if there are tolerations, then that pods can be placed on the nodes which have the same set of taints. If that taints match with which are specified in your pod specification, then you can deploy that pod, or that pod will be placed on that particular node. And then the last thing is topology spread. So how it works is, if you want to have your pods spread across your cluster which is running maybe in different region, in different zone, then you can use this constraint. And what it does, it to achieve high availability, you can use this particular constraint. And then moving forward, so Karpenter respects everything what we talked about in this slide. So for example, if you see here, it has defined multiple values of the instance family, C5, M5, R5, and then it has defined multiple instance sizes. So all the instance, nano, micro, small. So these are all this defines the instance family or an instance size what we use in AWS, and then it can be in one availability zone. It can be in multiple availability zones, and then it shows, what kind of CPU architecture you can define. And then you can define, whether it should choose spot instance or it should choose on demand. So if there is nothing specified, it will choose on demand. But if there is specify or spot and on demand, it will choose. Then moving forward, it also respects what we discussed before regarding the the labels. So it will respect that also, and it will respect everything what we have discussed, the labels and the taints. So if you have defined any labels and taints in your deployment, so Karpenter respects that and it follow that. And then moving forward, what are node pools? So the Karpenter configuration comes in a form of node pool. So what exactly node pool is? Node pool is a YAML configuration where you will define how Karpenter will deploy the nodes. So how Karpenter will provision the nodes. So it's a kind of YAML file, and this YAML file is responsible for provisioning and managing the group of worker nodes. And you can have a single node pool and you can have a multiple node pool. So the single node pool, it can cover multiple workloads, but if you want to segregate between two workloads, you don't want to share the node pools, and then you can go with a multiple node pool. And you should have at least one node pool, otherwise no nodes will be provisioned. And the last one is weighted node pool. So what does it mean is, for example, if you have two node pools and for one node pool the weight is 20 and the other one is 30, so the node pool which have the higher weight will be prioritized as compared to the other one. So this is how it works. So there is a weight 60 and there is a weight 40 on the other node pools. The one with 60 will be prioritized as compared to the 41. And then the next thing is, so beyond its core functionalities, Karpenter offers some other powerful advanced features that enhance its capabilities. So the first one is consolidation. So how this consolidation works is, for example, if you have multiple nodes running and that particular one node is underutilized, so Karpenter will move the pods which are running on that node to the other node which have resources. So for example, in this picture, so there are 4 different nodes running. If you talk about the first one, that is perfect. There are 4 pods running. If we compare to the other nodes, there are 3 nodes and they are underutilized. And if in your YAML file you have defined the consolidation policy as when underutilized, so this feature consolidation will work. So what exactly it will do is, so it will move those pods which were running in on different nodes to the node which has the resources available. And not only this, Karpenter is very intelligent. What it will do is, for example, in this picture there are only one pod running in on 2 different nodes, and it will move it to on one node. And what it will do is, if you notice, these 2 instances are M5 extra large, and it will move it to one instance, and even it will change. I'm not sure whether you are able to see. Even it will change, the instance family. So it will change it to large because those are the only resources needed by that pod. And then the next feature is Karpenter drift. So this feature helps in day 2 operations. Day 2 operation means when you need to upgrade your worker nodes or when you need to patch your nodes. So then this feature comes into place. If you have enabled this feature, what it will do is it will automatically upgrade. It will automatically patch your worker nodes, and it will with new AMIs. So AMI, as I mentioned, is machine images. So if there is a new machine images, it will automatically upgrade it to the new one, and it works in a a rolling deployment fashion. So one by one, not all at a same moment. Then, in August 2024, there is a release of Karpenter version 1.0. And with this release, Karpenter APIs graduate out of beta. So like any other, Karpenter open source project, Karpenter APIs follow a maturity, progression from alpha to beta and then to a stable version. And this release, it assured the customers that all the Karpenter APIs will move forward. If there is in future there is a minor, version 1. So all the Karpenter APIs will move forward. And this feature also have some new features. This version also have some new features, which will give you, a better control over how the Karpenter will, work with your application. And there is a link. You can read more about what are the new features which are added in this particular version. And this brings to me to last slide. And so the summary for Karpenter is that Karpenter is fast. Karpenter is simple yet powerful. Karpenter is cost effective. It's secure. It's Kubernetes native, and it is part of SIAG autoscaling community, and it's awesome. So yeah, that's it. Now I'll pass to my colleague Chakkree, and he will show a demo of this one.
Question.
Yeah,
Can I have a question?
Yeah.
Question about the API 1.0. Does that mean the Karpenter AWS provider or the core part? Because there's two parts, right?
Mm-hmm.
There's the core, and then there's the AWS and Azure and what have you. But does that mean that the this means AWS part of the Karpenter, right? Not the core.
Yes.
Okay.
Yep.
I guess if the question is if it is the core, it is actually the core. That is 1.0.
Okay, so the core will be 1.0, which
Yes.
is the
Yes, it
the
is.
Kubernetes
It
part.
Yeah, it is a project under the special interest group
Okay.
that released the 1.0.
Okay, so they will release the 1.0 release.
It's already 3 weeks old.
Oh, okay. Oh, really? Okay.
Any other questions?
Yeah. So my question is about that kind of a moving the load. Does it respect the daemon sets on the nodes? For example, like I have like, let's say, 10 daemon sets for some reason on my node, and only one pod with an actual business valuable load, which may actually utilize less resources than all those 10 daemon sets. So basically, I want to like to reduce the amount of nodes and respect those daemon sets. Basically, just ignore them. And like,
Do you want to, consolidate them into one?
yeah, I mean, I do not need those 10 daemon sets if my load, the business available load, isn't like working there on the node. Basically, they're useless. They're like, I don't know, CSI drivers, some Cilium ports, whatever. Yeah.
So you want to get rid of those?
Yeah, I mean, that doesn't respect that.
Yeah.
So there is like a flag, ignore daemon sets or something like that.
I need to check that.
Okay.
It
I need to
automatically
check that.
ignores those.
And one more question about this. If you have pods where you don't want them to be moved out, or when it is running on a node, some stateful pod or something, you don't want it to be moved around so many times. Is there a way to exclude those pods or nodes?
Yeah, of course, yes.
Yeah, you can do it
Yeah.
for that one.
Yeah. So he will show you in the demo.
But it's fine. Yeah, let's see. Okay. Yeah, I think it's fine now. Actually, I pre-recorded the video already, but I would like to show it live. So you can see it in action. Hello everyone, my name is Chakkree Tipsupa, a solution architect in AWS. I'm based out of Stockholm, and I am one of the solution architects that working in technical field community, just like Sanjoli. And yeah, I'm going to do a demo, and let's explore our environment first. So here, how many nodes that we have? So, yep. So here we have 2 nodes in our cluster. So this will run some kind of some functionality pods like Kubernetes and also some other pods as well. You can see down here in the screen as well that we have 2 nodes here, and this is the cost per month. And how many pods here were scheduled in those nodes. So here is the tracking of number of pods that already running, and the stage is running. There is no pending pod. So the Karpenter will kick in when there is pending pod, and they would like to have additional capacity. But for now, I think the additional pods can be run on the existing node. So let's see something else that I have prepared for. Let's see the deployment. So I have a application. My application is just a dummy that consume 1 CPU. It's called Inflate here. So now there's 0 replica. And then we have Karpenter. You can scale up like a Karpenter controller for control everything about node termination and also node provisioning. So this one you can scale up to make it more resilient by using like 2 pods for Karpenter controller. And just like I said, this one is just Kubernetes. And let's see our application, what kind of request that we request to Kubernetes, how much CPU that you want. So let's see here. Let's see the CPU request. There is no 10 toleration. And there is no AC specific or spread AC yet, but we will add later. This one I just would like to show you that this one is just like simple application or container or pod that requires just 1 CPU. And then we would like to scale this one up. Oh, let's see the node pool first. So node pool is the key for Karpenter that you can configure how Karpenter will behave. And you can have multiple of it, but today I will just show one of them. You can have multiple one. You can have like 1 node pool for workload which use CPU, and another node pool for the workload that use GPU, for example. So let's see the node pool configuration that we have initially, and we will change in time. So you can see the node pool is called default actually. So here what do we have? Let's see from the beginning. Okay, we will touch about consolidation later. So we change later. For now, if we do the consolidation when the node is empty, when the node is empty, we try to reduce the cost. The limit, Sanjoli already told you that the limit we can set per node pool configuration as well. Now I limit that this node pool can provision only maximum 10 CPU in terms of the instance. So it cannot provision more than that. And then let's see. Okay, we would like to use x86 architecture only. We will not include ARM yet. ARM is more cost effective and lower cost with the same performance, but you need to test your application whether or not it supports the ARM instance. And also for the capacity type, you can also use Spot, which is much cheaper when it comes to costs. But now we would like to schedule on demand. And instant type, you can just like use a wildcard that I would like to have my workload to schedule on the C type, which is the compute, the M type is the memory, and the R type, or something else. Yeah. So that is it for the notebook configuration. And now we would like to scale our application up. So I will scale like 5 replica. Yep, I will scale up to 5 replica. And you can see here that there will be some pending pod here already, and Karpenter will kick in because there is no capacity for these two to handle the pending pods. That's why it will come up with 1 node or more if needed. So let's see some logs, if we can see it. Oh, yeah, it's quite small. I cannot see it. Oh, here. It will try to select from these types of instance. If you can see here, a lot of them, and 41 more. And then it will try to find the one that fit 4 pods, 4 pending pods. And it come up with the, where is it?
And isn't it so that it finds also the prices of them and picks the cheapest one?
Yeah, pick the cheapest one as well, because that's why Graviton will come into play, or architecture will come into play. Is we try to schedule your pending pod on the cheapest EC2 instance. So let's see what kind of thing that Karpenter give us. So here is the C6A 2x large. So all of the pending pod here, four pending pod, if you can remember, will be scheduled here. But if you ask, so 2 additional pods is for kuproxy and another one is for kubelet. So yeah, it will be 6. Yeah, you will try to look into the cheapest one, and then how about we scale up again? I mean, the scaling can come from HPA or KEDA, depending on your design. Yeah, let's go to 20. And there will be some pending pod as well. Here, 12 of them cannot be scheduled. If you can remember, we configure the limit of this node pool to be able to spin up only 10 CPU. But I think they already use up here. This one maybe more than 10 CPU already. So it cannot spin up a node anymore. That's why we need to increase that. So if we check, there will be some pending pods around 12, just like here. 12 pending pod, and let's see, we need to change. We'd like to see some log as well. Yeah, the log will say that, so there is an error that it cannot provision because it exceeds the limit of the configuration that we did with the node pool configuration. So let's see, we need to change that. If you can remember, the limit that we set to 10, we can change that to maybe 1000. Let's see, I just patch that to 1000 in the node pool configuration. Yeah, hopefully it would come up with some other nodes to handle this like 11 pending pods here. Yeah, and the log will now working on finding the right size of instance that can fit all of the 11 pods. So it will be bigger than C6A large, or yeah, here's come. It's quite fast compared to cluster autoscaler. So it detect it and then it work with EC2 API, or in another cloud maybe call another name. Work directly without an auto scaling group at all. And we have it here, and now our pending pods are scheduled on, yeah, you can see here is the bigger 4x large. Okay, so this is in terms of the limit and how it scale and how it select the cheapest node for you. So let's see something else. So let's see that we would like to add the ARM, which is much cheaper, and also cost effective. So I put that, and we will revise the node pool configuration again. Yeah, we will see the configuration so that you can remember that which part that I'm talking about. So here in the limit, you can see from 10 it changed to 1000 already. And then from the CPU architecture here, we had ARM64, but I add one more. Is the we had AMD 64, but I added ARM64. So, it will try to detect that what kind of instance that will fit of our workload, and then spin up a new one and try to do the 10 and run that, call on and run that one to a new instance if we enable consolidation. But for now, we enable consolidation just for when it comes to the situation that the node is empty. So nothing will happen for now. But I will change later. And then what else we can do? We can also include spot, which is much cheaper compared to on-demand. Yeah. Spot, we can include it. Can show again. Here is the spot. I just replaced it. I just take it out. So you can put two of them, like both on-demand and spot, and it will prioritize the spot. But if you put only one, you try to schedule on spot if it is available at that time, at that AC as well. So here there is nothing happen because it will not try to do anything because it will do it when it's empty. It found the spot. So you can see that I forced them to use the spots because I removed the on-demand. That's why it will try to find spot for me if it's available. Here is spin up a new spot, which is X large only, and then try to schedule some on that. Yeah, to lower the cost of the whole cluster. And I think, so we will try to show some consolidation feature that when we have underutilized node, it will try to spin up a new node which is cheaper and then try to drain the pots for us to a new node. So let's see. So here we have consolidation when it's empty, but we can change that. You can also configure the time as well, like do the consolidation every 1 minute or 1 hour or something. So now to demo faster, I just change it to 20 seconds. So let's change this one. When underutilized, it will do the consolidation for us. Yep. So here we just revise again. That you can see on the top. Here it's already changed that we will consolidate when the node is empty or underutilized. So now it's not underutilized yet because you can see the CPU utilization is 60%. We will not try to come up with a new node yet. So we try to scale it down, our application. So now there are 20. So we try to scale down to 10. And there will be some nodes here that is underutilized, so it's already drained. Here, 32% of CPU utilization, and we will try to come up with a new node to handle this part as well, these 7 parts. So that is the consolidation feature. So you need to make sure that your workload can tolerate with the disruption so that you can enable the consolidation. And for the spot, if we reclaim it, for Karpenter, it supports spot termination handling out of the box. You can also try to do that as well. I have one customer that have they use a lot of spots, and one of the applications rely on the spot when it is available. They put spot and put the on-demand and they mostly use pod. Okay, the last thing is about the things that Sanjoli mentioned. Is about the pod affinity, tenant toleration, pod disruption budget, and everything that you configure on your deployment. Karpenter will respect that. I just would like to show one demo around the AC that we would like to spread the AC out. Like for now, I didn't specify anything. It can just spin up a node in AC-A, AC-B, depending on the Karpenter. But now we would like to spread out all the workload to provide more availability. Yeah, here it's try to do the consolidation. You can see spin up a new node and then kick out that node. And now you have almost fully, not fully, half utilized of the nodes here. Yeah. Last demo here that I would like to patch our deployment to schedule in different AC. You can just like use topology spread as well. Yeah, topology spread constraint here. And with that, if we try to rebalance, fortunately that for now, I think Karpenter already spin up a node in different AC, so it doesn't need to spin up a new one. So let's check the AC of each node, what kind of AC that they are running on. You can check in the console as well, but you can check via command line. Yeah, so here, yeah, it's try to do consolidation and yeah, I think this node will be gone. Yeah. You try to group the workload together. And here we have 4 nodes here, and then here is the AC. You can see that some of the nodes belong to AC EUS 1A, and some of the nodes belong to 1B, and some of the nodes belong to 1C. That is the node affinity or constraint and everything that you put into your deployment. Karpenter will respect that. And for the stateful workload, you can also accept this node for the Karpenter to be managed. So it will not try to drain the stateful workload from the node. So you can do that. I think that's all for the demo. Any question?
And is there a possibility to set any maintenance window, because for some applications draining them and moving them to others quite frequently might create some disruption, and for example, let's say application, there is a maintenance window at a particular time of day. Can you set that in the Karpenter?
I'm not sure about that, but I mean, so you can set the time when it will calculate the consolidation, right?
Yeah.
And the policy, but I'm not sure about the time. Do you know that? I'm not sure. Yeah, I need to check on that. Let's check,
Okay.
and we'll get back to you. Yeah. Yep. Any other question? Sure.
I'm using this quite heavily on a cluster where we run CI/CD jobs, and I've noticed that this is quite aggressive on cooling down the environment. And if we have a job or multiple jobs on a CI/CD and one runs on a node, and when the job ends, the node is gone, and the next job starts, and it needs to spawn a new node. So is there some kind of a cool down period that it just stay for a minute or two to see if there's a new job, so that it doesn't need to bring up and take down the nodes?
You can configure that one, including the consolidation as well. You can configure the cooldown period as well in the notebook. Any other question? So then we have Stephane. Not yet. Yeah, you will have a break. So,
No more questions?
so we'll get back to you on that.
Okay, let's have a break then.
Sure, let's have a break. Thank you so much for the attention.
Thank you.
Denis. I'm working at Relex and just going to present some thoughts on Helm and how I built a small Helm replacement. So let's start. So this is what we're going to talk about, a little introduction. Then we talk a little bit about Helm and its drawbacks. Then about my solution, which have its own drawbacks, of course. Then there is a demo and questions. So first of all, about me. I am a DevOps engineer or system administrator, whatever you wish. I'm working at Relex solution here in Finland, and it was my 1-year anniversary recently, in the end of August. I am living in Helsinki for almost 2 years now, and I like to build solutions no one asks for. And this is actually what I'm going to present. So first of all, disclaimer, since we're talking about Helm and stuff, we'll have some criticism of Helm, maybe. So it's fair to point that Helm is really great though, and you should use it, just because it's really good. What I'm going to present is just artifacts of learning and my curiosity towards other technologies and other approaches to solving the problem. So yeah, that's it. So first of all, a little bit of history of Helm. Originally, Helm was presented on the KubeCon in 2015. It was Helm 1. Then it was merged with Kubernetes Deployment Manager, and it became Helm 2. And Helm 2 was with two components: server, it's what it called Tiller, and then the client itself, the Helm. And Helm 3 was released in 2019, and this is the Helm we are using today. Using and love. Yes, so what is actually Helm is a package manager, and this package manager allows you to create your charts, Helm charts, which contains templates for Kubernetes manifests. And this is the breakout of just a simpler Helm chart. If you run command helm create, it will output exactly this structure in one of the folders you specified. So we have deployment, some other stuff like ingress and service account, and default values for this in values.yaml. Going through these files, we have the chart YAML, which contains the metadata about the Helm chart, and that's it. There's a version of the Helm chart itself and version of the application you are deploying with this Helm chart. There is also a type for the chart. There is also a library, which can be really useful if you have a lot of Helm charts, like building them. And description. So, and this is, in my opinion, where the problems begins with the Helm. It's the templates. Templates is a regular Golang templates, Sprig library, if I'm not mistaken. So yeah, you have a YAML file, or what is apparently a YAML file, but it's template, and you have like template all over the place. So you have some logic. For example, if we have value service account create, we then deploy this manifest. And there is also include, and includes different functions from the helpers, which will be on the next slides. And here we have indent. So yeah, we are templating YAML files. Of course, we need indent. So and there is a helpers, which we discussed a little bit on the previous slide. So there is logic. You are defining the function like chart service account name, and then you're using it with include here. There is some logic, if, else, and so on. And
this is like not good in my opinion. It's really hard to work with because I wrote a few Helm charts and it become messy really quick if you're doing something like complex. And values.yaml is just a YAML file, regular YAML file with your default values, which you can override. And this is the section for the service account previously. So this is the parameters will be used to template or not even create the manifest for service account. So, and this is the problem as I see it. This is the misuse of YAML. Because from the YAML.org, YAML is a human-friendly data serialization language. And why we even templating human-friendly language before sending it to the API of Kubernetes? I don't see like a value here sometimes, because yeah, we indenting files and so on, but then we'll just send it to API, which will be processing it as a JSON, I guess, or Golang data structure. So the idea is maybe stop templating strings, and maybe instead we will populate typed objects with values. And we may use some recently open source configuration language. Do you know what it is? Do you have any ideas what this apple and cucumber means? Okay, it's apple pickle. It was recently open sourced, and I decided to write Helm, which is just a Helm clone. Dollar store Helm clone, I would say, because it's pretty limited what it can do. So it's high level and type aware Helm clone. And we're using apple pickle for templating, for constructing Kubernetes manifest. And I will show. First of all, apple pickle, it's pronounced like pickle, and it's built by Apple and open sourced earlier this year. By the way, it's not a CNCF project, and as far as I know, they don't see it coming to be an CNCF project, but it's okay. I think Apple have like some money to develop it. And the first commit was in 2016, if you check the repo. So it's 8 years. 8 years in development, and it's actually pretty mature. Yeah, so it's, to give you the quote from the site, it's Pickle is an embeddable configuration language which provides rich support for data templating and validation. It can be used for, from the command line, integrated in build pipeline, or embedded in a program. Pickle scales from small to large, simple to complex, ad hoc to repetitive configuration tasks. So, and yeah, I totally agree with this quote after working with Pickle a few times already. So it's Turing complete, it's written in Java. LSP support, official LSP support is on the corner, but there is an unofficial one, community one, and the community growing really fast. Why it's called Helm? Because it's written in Pickle language, and I just replaced the first letter. And this is exactly what we'll get instead of Helm if it was downloaded from a sketch website. And of course it remembers me about pelmeni. Since I'm Russian, and some of the people from my Slavic brothers and sisters maybe know what I'm talking about. But anyway, so what we have, instead of Helm charts, we have Helm jars, and of course this this is exactly what I'm trying to do. I'm trying to do kind of similar names, so it's not Helm charts, it's Helm jars, because it's kind of funny, and maybe at some point someone accidentally, just one misclick, just one typo in the search, and accidentally you installing Helm jars into your production Kubernetes cluster instead of Helm charts. It will be funny, I guess. So yeah, it's almost exactly the same structure. We have helpers. Instead of chart YAML, we have jar pickle. We have Helm itself. And there is render and templates. Templates is a meat of this. And we have values pickle. And later we will go through some components resembles. We're going through the resembles with Helm right now. So this is I showed you the chart YAML, and this is the jar pickle. This is actually the same. It's just a different language. This is just strings with some values which will be used. We have a version of our Helm jar, and we have application version. So, and this is where the fun begins, because this is now the service account template manifest. So first of all, Pickle have a library with all the types for all the objects in Kubernetes. So you can see I am importing it on the top. So it's API core v1 service account. And as soon we imported it, we have this structure. And it's not a free form, it's typed. You can't use like different like fields here. It's just name, namespace, labels, what the actual object in Kubernetes have. And there's a logic. So once again, if we have values service account create, we will create this account and populate it with values. If not, we are not creating it. And no indentation needed. If there is annotation, and annotation already a dictionary of, it's a mapping of strings to strings, so that's pretty simple. The syntax highlighting is kind of bad here because it's not in the library I'm using for these LaTeX presentations. So I found Kotlin works the best, but not exactly, because else and null in the same color, so it's maybe confusing, but it's good enough. And also I showed you the helpers TPL in YAML in the Helm, and here how we do it here. So here's the logic, but it's like kind of nicer, less of the like curly braces for sure, and that's it. So, and this is the values pickle. This is the first like big difference in my opinion, because in Helm you just creating the values YAML file. You don't have any types, you don't have any classes declared and so on. You just creating YAML file and just getting the values from there. That's it. But in Pickle we need to create the classes and default values and so on, and use type language for that. I will show it a little bit later. It have some advantages, of course. When you have a typed objects, it's always an advantage. So yeah. But the support of YAML, of course, are built in Helm as well, and I will show it later. So, in comparison to other tools, so it's really hard to compare something compared to something, because Helm has 9 years of active development in its really nice product, and I just, there's nothing to compare. Customize have a different strategy with patches and bases and so on. There is also KPT created by Brian Grant, which was the original lead architect on Kubernetes, and created kubectl and Customize. So, and
I have a question here.
Yeah.
Have you played around with Tanka? Have you played around with Tanka, the one by Grafana that's using JSON-net?
Oh, not actually. Actually, no.
Yeah.
Actually, no.
Me neither, but I just read about it and got excited to try it at some point.
Okay. I want to check it out then as well, because JSON-net is actually what I kind of missed here. So KPT solving the different problem. covering all the deployment from top to bottom. I have like graphical interface, but it's kind of interesting project nevertheless. I just learned it while preparing to the presentation. And the Helm, on the other hand, I just don't like the templates of Helm. And that's it. I like the Helm, and I even like the template of Helm, but it can be improved a little bit. And this is just the difference between Helm and Helm. So, and we are already in demo. So we will create a Helm jar. We will change it according to our needs, because I want to showcase how you can change the templates, change the default values, and we will deploy it to our fresh Kubernetes cluster. Yeah, let's try it. Let's go here. Okay, so first of all, is it big enough for everyone, right? Okay, nice. So let's create directory jars, and of course cd into. So this is where we're going to create our jars. So, and to create a Helm jar, it's pretty simple. You have Helm, create, and then the name of our jar. So I'm really like to use the Quart for the demonstration in actually Kubernetes up and running demo. It's a small binary, it's a small web server which showcases some information about the pod running, environment variables, and so on. So it was written by Casey Hightower, I guess, if I remember correctly, for the Kubernetes up and running book. So that's that. Yeah, we created our first Helm jar. Yeah. And let's check the structure of our directory. So there is all the files we needed. So first of all, there is our jar.paml, jar.pickle, where we have the name, we have the versions, and this is where we're actually starting to do changes, because the default jar templated with Nginx, and this is the version of Nginx, because this version of course used as a container tag. So, and for Quart we have a different one. So let me change that. And if there is a few colors you can change, you can choose. Let's get blue one, because this is the actual tag of our container we will be using later. So, and yeah, if we can also change this one to something like this, and let's save it. Yeah, and this is our metadata, which will be used for templating our Kubernetes objects. Next one is our templates. Values pickle, because we have a different container image, and we should change it, because the default values stored in values pickle. And just to showcase you, not to showcase you. There is actually there is a command in Helm to output the values, and I will show it later. So there is our values YAML, values pickle, sorry, and we can go through it to the actual values. So we have the default values here, where it's specified, and here we have our repository. So it's Nginx, and it should be different one. If I GCR IO. Is it Quar demo? T64. Maybe it's not a good idea to do it like, maybe I should copy it, but I hope it's the right one. Yeah, so we will save it.
Is it Quar demo or Quar?
Yeah, it's Quart because it's QR demo. So they have a QR demo, then Quart, and then AMD64. It's for demo purposes, so it's kind of confusing. Yeah, and so that's that. That's that. We already populate. We already done something, but this is only the beginning. Only the beginning. As soon as I remember how to open like horizontal split. Yes. All of a sudden, side note, I just have a different keyboard layout on my laptop and the keyboard I'm using, so it's a little bit annoying. But yeah, as I mentioned previously, we have helm values. We can specify the current directory, and if we output it through the YAML queue, we will get the default values. So that's that. So, and as you can see, we already changed this image, and this is like displayed here. So, and let's deploy our Helm jar into the Kubernetes cluster. Is it connected? Yeah, there is a Kubernetes cluster. And let's create a small create a YAML file with our overrides, because you know in Helm you have different values for different environments, and of course I have it here as well. So we will be changing the service type and the port. So let's create a new file. Let's insert it here, and let's save it as values meetup.yaml. Okay. Let it be load balancer, because we want to see it, and we don't have ingress controller in our cluster, and it can complicate things quite easily. And the port will be 8080. So, and yeah, let's deploy it. So how to deploy it? First of all, we have Helm template. Then we specify the name of our release. It would be Meetup port. Then there is our directory we're currently in, and let's specify values. And values will be our values.meetup YAML. So the template will just output the YAML configuration we are going to deploy. So, and this is our services, our deployment, our service, and service account. So, and you can see we have the Meetup quart in the labels. We have a different name, we have a different namespace, we have a different port, service with type load balancer. Where is it? Yeah, it's here. So it's working. And let's install it. And to install it, you need to run the Helm install. And actually, I tried to copy the Helm command line interface where I can. For example, if we want to create namespace, we can use namespace, and it will be quart meetup, and it will be, and we need to create this namespace.
You made a slight typo.
Where?
Namespace.
Namespace?
Quadr.
Quadr.
Yeah.
Oh, nice. Yeah, thanks.
I'm good at this kind of shit.
Okay, yeah, and you can see I'm not even trying to hide. This is output of kubectl, which is under the hood applying these manifests. It's not a real project, of course. Yeah. So we're just templating this, using the templates outputted by Apple Pickle and just using kubectl to apply it to the Kubernetes. And let's check what is going on inside our Kubernetes cluster. So, yeah, let me do it a little bit, a little bit smaller. Okay. So there is our quart meetup. There is our pod running. It's getting some health checks, readiness probe, and so on. And in our services, we have our load balancer, which is pending the external IP. And while we are pending, there is actually one problem, where we can improve our chart, our Helm jar. It's so complicated, it's so hard to remember. So let's see. So we have port, and the problem is what this port used not only for the service, but actually as a container port for our deployment. And this is a problem because if you specify 80 here, the deployment will fail. Not the deployment, container will not start because it don't have permissions to be in the port less than 1024 or something like this. So that's bad, but I want to use 80 port, like default HTTP port. So this is where I decided to showcase the demo how you work with these pickle templates. So what we need to do first, to go to our values pickle, and we have our service. Where is it? Somewhere? Yes. So here we can add new field, container port, and let it be. Yeah. Let it be 8080 because it's the default port of the quart, but it's only the default values. And to do it properly, we need to go to the definition of the service. Is it going to go to definition? No, it's not going to go to the definition. So let's search it then. Service. Yeah, that's. Yes, this is our class. This is where it's really different because you're not only specifying the fields itself, you need to specify the type. So, container port, and we're using just integer, but actually, you can import the type aliases for the ports because there is 65,000 something ports. They can't be negative and so on, and you can use that. But for the simplicity, I just use an integer. So, yep. So after we added this, now our Helm jar are already aware of the changes. So, but we are not using it anywhere. And to use this new container port, we need to go to our deployment pickle. This is pretty straightforward. It's not really big. It's, yeah. And here we have our containers. It's like pretty similar to the deployment. It's just a deployment manifest, but written in a different language. So, and here we have the first problem. So we have container port, which is port of the service. And this is not good. This is where we actually going to do the first change. So it's going to be container port. And then if we had LSP, it would be easier. But for now, we just type in out of my head. So now we will be using container port. And this is already a big change, a big step forward. But for example, I want this container port to be actually sent to as an argument or to our core, to our pod. So let's do it and let's showcase how we can do it. So we have a command which will run on the start of the pod. So, and we are specifying the new listing, yeah, and this is actually the name. I will showcase output in the YAML, but actually it's pretty simple. So we are running the quart, and as args, it will be a new. Would be a new listing, and we will have, if I remember correctly, it will be dash address, and the next one we will specify our port, and we will do it like this because it's a string. Yeah, this is a string, and we can just copy this one from here, and let's put it here.
I think
the address.
Sorry, I think the address is too. Yeah.
Yes. Yeah. Thanks. Yes.
I like the way you read my mind.
Yeah. Thanks. So, and that's actually it. So now we changed our Helm jar a little bit to our needs. And let's first, before we will deploy it, let's check our Kubernetes cluster, and do we actually have our external load balancer provisioned? Yes, yes we have. It takes, oh no, come on. Hopefully it's copied, because, yeah. Let's go here, here. Not. Oh no. It's not copied. Yes. It's not going to work, of course, because we need the port 8080. And this is why I want to use the default port. Is it working? Yeah. Ooh. So, and this is our deployment. This is what we deployed to the Kubernetes. Like nothing special. This is the quart. It's really nice for demos, but be careful because it exposes some sensitive data like environment variables and so on. And file system browser here, so it's just for the demo purposes, nothing else. Just to let you know. And yeah, let's now see how it goes. So let's now template our Helm jar, but first let's change the values we specified as an override. So now we have the port, and we can use it as 80, and now we can specify container port. And we even go further, let's do 9000, because now we have propagated it through this YAML file to our deployment, to our service, which will run in the container. So it should be good. Yeah, and let's check our manifests. Let's template it, let's output it. So service account, no changes. So service, it's changing the port. And then we have Yes. This is what we done with these new curly braces. So this is the command, this is the arguments, and it should be working now. And let's install it. We can delete create namespace. Yeah, I saved everything. So you can see the deployment is configured, the service configured, and the service account unchanged. Let's check. Yeah, so service changed the port to 80. And pod. Yeah, and pod is running. And here in the here you can see we propagated the 9000 port to our workload. So this is exactly what you're doing usually with Helm, with the templates and so on, but now it's a little bit less stressful, I guess. So, and let's go to check it out. So this one should fail, of course, because now we're using the default port for our load balancer. Yes, it's that simple. So, and I guess the last thing I just want to showcase what the Helm is actually have the capabilities to package your jars. As you do it with Helm, you're creating the tar.gz archives, so you can use Helm package and then use the directory quart. Yeah, and it's creating this. All of a sudden our non-default values got inside this tar.gz as well, but I'm not bothered to like change. So yeah, and it can be distributed. That's the demo. So going back, it went quite smooth. So what the drawbacks? It's like in prune capabilities. Like you deployed something and it's here to stay in your Kubernetes cluster, because Helm actually doing pretty nice stuff. They are creating the secret with the full manifests of the release and some and they versioning this secret and so on. But I don't have this. This is why it's just like in these capabilities. Then there's complex logic in templates can ruin the fun because still it's Turing complete language and it can be really messy. I spent quite some time to write the function for merging deeply nested structures, but yeah, it's not even in demo. Why? Yeah, so there is no registries. The zip, the gzip archive we created, you can just send it in Slacks to someone, but that's it. No OCI or jar museum or something like this, and never will be, I hope. So this is a drawback, I guess. It's written in JavaScript. It's just a wrapper around some CLI tools and nothing else. But almost all the logic written in Pickle, Apple Pickle, and we are just calling from the JavaScript Pickle binary. But there is actually like really good bindings to different languages for Java and Golang, for example. So it's easy to implement in a good language as well. And it's probably only working on my machine. I don't know, I never tested. So this is the drawbacks I see here. So, and yeah, there is some links to this before we go to the questions. So this is this code available on GitHub. Also there is a presentation available on the GitHub because yeah, now I'm writing my presentation in LaTeX. So there will be code as well for my presentations, not only for Helm as well. So, and additional links, it's awesome Pickle, check it out, it's really nice. Then there is an issues, kinda interesting ones, because The first one in Apple group, in Apple project, it's asked for supporting OCI registries for pickle packages. Sorry. Yeah. Then there is actually a really interesting one in Helm, because people already asking, can we adapt pickle instead of these horrible templates? And people just, well, it depends. It's kind of hard, because just imagine how to like rewrite it, and what the painful it will be to switch from like Helm 3 to Helm 4, for example. For a few years it will be just such a burden. And there is actually also an Nginx pickle. It's Nginx pickle chart, as it states, but someone else, which I found interesting. So people kinda, it's not a new idea what I'm presenting. People are already kinda, oh yeah, can we just use it everywhere? And that's that. So yeah, that's it. And now if you have any questions, I would like to hear them. Yeah, go ahead.
Not a question, but I just gave you the first star in GitHub.
Oh, thanks. I really appreciate it. Thanks. Yeah.
Do you know why Apple open sourced this, and what are they using that for, typical?
It's really hard to tell, but I think since there is a really nice support for Kubernetes, I think they're doing a lot of stuff in Kubernetes for this with the pickle, because it's done on purpose, I guess. If they have the big library of typed objects for all the.
I'm thinking that it must be tied to Kubernetes because they have the Kubernetes library, but what are they using that for?
I think they're using it for everything, because if you go to the pickle link, there is package docs, and you can find all the packages here. There is standard library, there's Kubernetes one, there is something for Circle CI, for influx data, for Prometheus as well. So and there is kinda a lot of them.
Most likely Apple just don't like anything that is invented by someone else than Apple.
Well, typically they keep it themselves, but now they open source it, so.
Yes. Well,
they're slipping.
Yeah, it's really strange. I don't know how to. Since I'm not working in Apple and never worked, I don't really know what they are thinking. But in my opinion, it's really nice. It's really. From my personal view, it's really easy to work with pickle. This is why I'm shilling it as like crazy everywhere. Because we have, for example, QLang, and I worked with QLang, and this is just wow. Please no, because Apple Pickle is just much better. But it's pretty new project. It's really new, even though it's started developing in 2016. It's really new because it's open sourced in February or something like this, in the beginning of the year. So it's still kinda mature, but not really, by the open source standards, I guess. So yeah, you can output TOML files, you can output Lua, because, for example, Lua, I think it's where they trying to do something maybe for Nginx, because you can, instead of writing these horrible Lua snippets for Nginx, use something, some nice language, and then output it as a Lua, as a horrible Lua snippets for the Nginx. So, yeah, just my recommendation to check it out. Yeah. Any more questions? Okay, if not, or if you have like anything to like ask, we can do it here privately. I will be here. So, yeah, thanks everyone.
Thank you, Denis. Let's have like a very short break and come back, like 5 minutes.
Okay.
How am I doing that?
Yeah, good.
Probably one in my phone. Let's get that out of the way. Let me know when you can read what's on the screen. So it's done. That's big enough? Alright, okay. Okay, that was not the right terminal. Oh yeah, I will move a lot. You're gonna hate me. Yeah. Okay, that should be good. All right, so thank you everyone. My name is Stephane. I work for used to be a small company called Isovalent, but now part of Cisco. So I failed escaping Google to work in a startup. A year after that, I'm now working at Cisco. I love that, by the way, if my manager is watching that. That was a very, very good move. I love WebEx. So I'm French. So it means two things. First of all, I apologize for being late today. I was supposed to be the second talk. Thank you very much for taking over. Highly appreciate it. So that was the first issue. And the second one is my accent. So you can blame that when you don't understand something, right? You just say, I understand what you say, not the way you say it. And just use that and ask your question. So today I'm here to talk about two topics. Zero trust and how do we implement zero trust with Cilium, observability. We're going to talk about many, many things, but it really depends on you. So first of all, who has never heard about Cilium before? Like ever? I'm so sorry. That's him. Okay, that's perfect. eBPF? Never heard about eBPF before? Okay, one person. Okay, so we don't need eBPF today. We're not going to do that. I'm going to talk about Cilium, so I'm not going to introduce and explain how Cilium works, because it's not part of today. But if at any point in time you have questions because you don't understand, just raise your hands, don't wait for the end, and then I can explain context and concept. I don't have slides, because I'm lazy, but I draw, and it's ugly, but it helps. So if you have questions, just stop me, and we can go with that. Is it clear? Yep. All right, let's go. So first of all, when we talk about zero trust, that's the first question. Why are we even mentioning zero trust? It's not a new concept in security. We've been doing zero trust for a very long time inside data center. It's not new. It is new for one category of people, platform engineers, and especially the, I cannot change that. It's a Cisco thing, but I love Cisco, love WebEx. Is it? It's just gonna, okay. I'm just gonna move my left hand. So, what am I saying? Like another joke? Oh yeah, zero trust. So it's new for platform engineering. Why? Because Kubernetes brought a new category of people, of deployment, a new way of deploying my application, which is, I don't really understand what I'm doing, but if I helm apply, it works, right? And you can do many, many things over, I took helm just for you. I normally say kubectl apply, I changed that just for you. So it means that we can create scalable platform that will host millions of users without really understanding the way it works, but trusting the system in a way that it will reconciliate. If I ask for a pod, I'm gonna have a pod, it's gonna auto-scale, it's gonna be perfect. Before working at Isovalent, I worked at Google, on the GKE SRE team for a few months, and we were 5 people, and we were managing more than 25,000 clusters with 5 people. No idea how that works. I couldn't tell you how it works, but we had automation, we had the SRE tooling and everything, and it just works. So there's something magical, that's my point, about Kubernetes sometimes, for the good and the bad. And security has always been the same thing. Security for a very long time was, I have my data center, I know it's safe because I have a security team. I used to deploy on VMs, VMs are safe because I have a security team. And now I'm doing the same thing, I'm just creating a box. My box is a cluster, Kubernetes cluster. And because everything around me is safe, I'm safe too, right? And Kubernetes was this perfect area where you could just deploy and you don't really care about stuff. And guess what? If something wrong happened, it's gonna reconciliate and it's gonna correct himself and it's just gonna work, and we've been doing that for a very long time until security teams start asking questions about what's going on inside of your Kubernetes cluster. Because actually one thing that people are very good at is that once they get control over a little thing, oh yeah, I have to touch the thing, thank you. Yeah, I have some Italian blood also. So something that people forget about is that when you are inside a system, one of the first things that you're gonna do is probe the system, right? So once you're in, then you spread. It's like COVID. So actually you cannot trust your container, you cannot trust Kubernetes, and guess what? Platform engineer understood that Kubernetes doesn't really exist. Container is a scam, right? Like you're just on a Linux machine. It's the same place, like you're not somewhere else. It's actually not a magical place. So if you get compromised, everything is. If someone gets a root access, goes outside of your container with route privilege, you're doomed, right? So that's where this idea of we have to do security in Kubernetes comes from. And the biggest issue is that because it was a different world, it was handled from the beginning to the end by one single team. This platform engineer team, these people who are supposed to know everything, right? This DevOps also, some people say, like you know everything. From the beginning to the end, you do security, networking, CI/CD, you do everything. But you can't, right? Myself, I come from the ops side. I knew nothing about Linux, like nothing. Now I do for my manager. But that was very new to me. And that's new concept. So I'm getting there. The idea of zero trust is to take one step back and to say, you cannot trust anything. So you start by thinking about your system in a way that your system is compromised. All the time. Your system is compromised. It will be at some point. So if my system is compromised, how can I make sure that it doesn't get probed, that it doesn't spread? And the only way is to limit access. And the only way to limit access correctly is to list everything that is allowed. And that's basically zero trust, right? The idea of building zero trust is to say, I'm gonna list everything that's allowed on my system, make sure that container, application are who they are, and if they have access and right to communicate, it's because I allow it. So I have full control over 100% of what's happening. It's a good story. It sells article on Medium, I've been there. But how do you do that in production? You didn't remind me to move. So how do you do that in production? That's today's story. So now I'm gonna speak even faster and show you how that can be done in a real kinda environment. So for the demo today, I have a very simple environment. This is running on AKS. I'm very sorry. So if there is an issue, it's because their system is very bad. And this is two clusters meshed together we have a technology called cluster mesh, so Cilium cluster mesh, so you can mesh them. So the services can communicate from one cluster to another. What you see here is called Hubble, if you've never seen that. During the presentation, I might say Hubble because I'm French, but there is an H, so it's Hubble. If I change the namespaces here, and I go in Kube System, and I go inside my live view here, and I start looking at my cluster, you might see something interesting. For example, two metric server, and the first one is running on cluster 1, and the second one is running on cluster 2. So you deploy your application, you just have Cilium running on your Kubernetes cluster as a CNI, as a container network interface, and you have what we call this service map. There's service map, that's step 1, so I know what's running in my clusters. And then there's these flow logs, bottom here, that we're gonna use today. Flow logs are telling me what is happening on my cluster. So there's communication, it's like doing a TCP dump or a Wireshark, but on your containers. And it doesn't require service mesh or any tooling or nothing. That's just coming from the telemetry of your network, of your CNI of Cilium. Now, for the topic of today, I've deployed a very simple application that we call Endor demo. So it's a simple app, right? I just kube apply, I have the TIE Fighter and the Death Star, and I can see communication between the TIE Fighter and core DNS, and communication with the world. So I know that there is communication here. So that's my application, day 1, I'm new in the company, and I need to apply zero trust to this app. So the way it works with Cilium and other CNI is that we deploy Kubernetes network policies, right? So there's two ways of deploying this network policy. You can do YAML, if that's your thing. Or you can use with Cilium, you have this editor, and you can use the flow logs here at the bottom to create policies. So you could just create a new policy and say, I like the traffic from TIE Fighter to Destar, add rule to policy, it writes the policy for you, and then obviously we don't apply that to your cluster. Then you download, you go through your GitOps thingy, strategy, and you deploy that on your cluster. That's the second way of building your network policy. Now, one thing that is extremely important with Cilium is what happens if I deploy this network policy. So we can play a game, maybe some of you already know. Let me go back here. So let's say I deploy a network policy and I say TIE Fighter is allowed to talk with the Destar, and I apply that network policy. What will happen to my cluster? Does someone know?
Everything else is denied.
Exactly. So the way Cilium works is pretty simple.
Exactly what you wanted.
Exactly what I wanted. If I say TIE Fighter is allowed to talk with Destar, then remember the zero trust rules is that now I have a system. Right now there's no policy, so everything is allowed. But at the moment when I say now TIE Fighter is allowed to talk to Destar, I haven't said that TIE Fighter is allowed to speak to Walt, or TIE Fighter is allowed to speak to Guardianess, or the Destar, or maybe Walt is talking to Destar, or any other communication inside my namespace, it's namespace based, will just be dropped. And that's how you break production. And it's pretty easy, right, to do this, have this type of mistake.
How about if the Death Star explodes?
Yes.
Is the communication with others allowed then?
No, unfortunately. No, the cluster might
Nazis will come behind the moon.
Exactly. Yeah, I come from Germany, I cannot do that joke anymore. So, one thing to know then is that the biggest, I would say the simplest way to go through a secure environment is observability, right? It's always the best way to start. So the thing that we had to add to Cilium was a way to understand everything that is happening, send as many metrics as possible to solve that issue. So now let's do that step by step, and we're gonna solve that. So first of all, we're gonna deploy my favorite network policy. It's called Allow All Network Policy. You can see the name here, best network policy ever. Doesn't change anything, but it's just allow the traffic inside my cluster. So it's a network policy that says, you know what, inside that namespace, everyone is allowed to speak to everyone. And just like that, I just saved my job. Because now I have metrics coming from Cilium that are actually telling me which network policy is allowing the traffic inside that namespace. So I have a graph and a dashboard for you, hopefully, yay. And you can see colors on that graph and a dashboard. And if I go at the bottom here, I can see traffic from a namespace, and I can see that it's actually allowed by this allow all network policy. So now I know that there is a network policy allowing all the traffic on my cluster. But a good thing, and you're gonna see where I'm going, is that there is type of a hierarchy of network policy. If you have a network policy of higher level that allow more, then it has privilege over the other network policies. Which means that now I can write another network policy, so I can go back here, go to my policy editor, select TIE Fighter to, let's say, Guardianess. I cannot do that because it's host network. Anyway, so TIE Fighter to Destar, add rule to policy, and voila, I have my network policy. I can just apply, and I know that if Cilium works correctly, I'm not gonna destroy production because I'm already allowing everything anyway, and I'm just allowing on top of it. But something is still missing. With multiple CNI, you wouldn't have a lot of information between TIE Fighter to Walt. Because how do you build zero trust if I have to allow, because in order to solve that mystery, I need to allow communication to outside. That's not zero trust. If I'm like, I need communication to anyone outside, I just broke the rules, right? I'm just allowing everything. So that's where Cilium is pretty smart. So right now everything is done through eBPF, because everything is what we call layer 3, layer 4. I'm just opening port and protocols. but you can do what we call deep packet inspection, so layer 7 observability, by using our Envoy proxy. And the way it works, pretty simple. You just write a layer 7 network policy, and automatically the BPF program changes and start redirecting the packet to the envoy, and then the envoy back to the source. And then you're like, but what about the latency? Well, the way BPF works is that the traffic doesn't really leave the socket. It's the hook at the BPF layer is before the TCP/IP stack of your kernel. So even if you Wireshark the traffic between envoy and your container, you wouldn't see anything. Because when you think about what's traffic, right? Again, I cannot capture packets, right? It's something written somewhere, read by someone else. Like everything is a file system. That's the beauty of Linux. So we just play with that game a little bit to help us with the proxy. So again, we're just going to write a very simple layer 7 rules. So I have a rules that will just allow packet to core DNS, but I will specify a match pattern on the DNS query to match any DNS. So it's basically a dumb rules that say everyone is allowed to call to DNS, but only if the pattern match any pattern. So again, not a crazy rule, doesn't serve any purpose, but at least I'm gonna get this observability. Here you go, deploy my rules. Now I need to wait for traffic to happen, here you go. And now I can see that actually this traffic that was going outside was actually going to disney.com or swappy.dev. So now I know that if I want zero trust, I have to write not a rules that go anywhere, but actually to disney.com and to swappy.dev. And again, if I do that, I'm not gonna break anything because I'm already allowing everything on my cluster. So let's just deploy, oh no, we don't even have to do that. Something else now, if we go back to Grafana, here you go. Now we can see blue. So, oh no, why am I done? What have I done? What have I done? Okay, here you go, now we can see blue. So, and if we go down here, we can see that I have this new layer 7 DNS policy, so the one I just deployed, that is handling traffic from the TIE Fighter to my kubedns. So now you can go back to the platform team with a very nice dashboard and tell them, I have a game for you. In a week, there is no yellow left. Right? So they just have to go through the entire set of communication that they can now see, because they can see everything in their namespace. They cannot break anything because there is actually yellow that is protecting the cluster. Everything is allowed like it was before. They can write their network policies. And when there is no all that are seen here, then they feel confident that, okay, now you can delete that. Will it solve everything? No. Is it the only way to go to production? Yes. It's not perfect because potentially a communication that has never happened before now will happen and was necessary, and you're gonna break everything, right? So it's not perfect. It's not AI based. I can guess the future of your traffic. Like, yeah, sorry. Even Cisco cannot do that yet. So because we don't have that, you just have to go step by step. Obviously, if you don't want to write all of your network policy, you can use the editor. So that editor is available in the Cilium project online. So everything you see today, by the way, was part of the open source project, not the company I work for. So you can have access to all of that. One last thing I want to show you is if you don't want to have this layer 7 network policy, another way of knowing what is happening is to use another tool called Tetragon. Has anyone heard about Tetragon before? Yeah, so it's a project which sits behind Cilium under the same umbrella, which is also using eBPF, but not to networking, but for runtime monitoring and observability. So for example, if I go back to this process and I look at one of my containers, so the TIE Fighter container, I can see the entire process tree, hopefully, yes, of what is running inside my container. So I know that this container is actually doing curl request, and I can see the destination of this curl request. So you can go further and go back to your developer and be like, come on, there is request to Disney, and they're like, no, there's no request to Disney, and you can be like, there is a curl command inside that container that is actually curling Disney.com. And you can write tracing policy to block that also. So Tetragon can block and enforce runtime so that you can say, no, no one is allowed to go to Disney.com and kill the process before it happens. So you truly have zero trust in a way that you can control networking, you can control process execution, so nothing can escape. And I know that nowadays, there's a lot of AI-based ML models that will say that they can solve this, but you cannot control what you don't know. That's just something no one has a solution to. There's no AI that can predict what hasn't happened yet today. Which means that something will happen at some point. Someone will find a new way to go inside your container. Not so long ago, someone worked on an open source project for years before putting a backdoor inside a program that was used by millions of people, and it was just pushed everywhere. Who would have guessed, right? Happened, will happen and happen again. So the only way to have a secure system is just to say, okay, you can talk to you, and that's it. That's the only thing that is allowed to happen. Am I on time? All right, yeah, I'm normally never on time. Do you have any questions? I can explain concept and stuff if I have time. Then if something was not clear about how it works, the redirection, the capture of packets, absolutely anything you would like to know and see.
Yeah, you know, one question. Sometimes when you have such strict rules and so on, when you try to debug something and you go inside container and in it curl, maybe do you have like any answer how to do it? How you can like kind of tightens these rules for certain amount of pods or time and so on, how for doing debugging, or what your recommendation is?
No, that's a very good question. My recommendation will then be to, first step is to always know who is allowed to deploy what type of network policy. So I always recommend to people who are using Cilium to work with something like OPA, Gatekeeper, Kyverno, something like that. Because everything you're going to do with Cilium goes through CRD, which means you can choose what is allowed to do and not on your cluster. Which means that you could say, I trust you to make the right decision, and if you need curl, guess what? You can deploy a network policy in your namespace that allow it. Right? I will always go in that direction. And if I don't trust you, then you should not have the right to do that. And then they will use Kyverno, write rules, and say you can deploy network policy, but only in a namespace, only if you specify a port. Like you can do many things with Kyverno that are pretty powerful.
Okay.
Okay, thanks.
Yes?
Question about the, you mentioned the L7
Yes.
and the envoy
Yes.
and the latency.
Yes.
Isn't that something that the envoy will add latency when it's doing the L7?
For sure.
Okay.
Yeah, that's a very good
maybe
question.
I got it wrong that it doesn't add.
No, that's a very good question. Yeah, there is no magic, right?
Yeah, exactly.
So doing something
I
always
thought
costs.
you were running the envoy inside the eBPF 50
Yeah.
or something like that.
So that's good. That's a very good question. So the community of Cilium is trying to replace some of this layer 7 work and put it inside eBPF. But the way eBPF works, it's a safe space because it enforces many things. Like the way you write your programs is very low. It's low C, no library, number of iteration, loops on you to eBPF. Like there is a lot of rules. So writing envoy in eBPF hasn't been achieved yet and wouldn't probably. So they're trying to see what they can do. There are some examples of HTTP header parsing through eBPF just to prove that it was possible to competitors and all of that. So in the future maybe, but when you think in the last 5 years, most of the CV I've seen on Kubernetes were actually coming from ingress parsing HTTP, because the number of CVE that are targeting HTTP are extremely high, right? It's a very hard protocol, so it's pretty easy to find issue in it. So I don't want to be the person who write the new HTTP parser, and Envoy is doing an incredible job at that. So yes, there is a price. The highest price is not even parsing, the highest price is encryption. Some people use Cilium to encrypt with WireGuard and IPsec. That's where you're going to see the difference. Otherwise, Envoy in our setup can handle, I actually heard my CTO say that yesterday, we have a customer that is using Cilium in a production environment with 8,000 nodes, big cluster, big customer, 11 million packets per second on Envoy, no issue. So it's okay. And they are bank now using Cilium. They have stock exchanges using Cilium. So latency is pretty low, but it does exist. You're right. Yeah. Any other question? Things you would like to know? Perfect. Does zero trust make more sense now? How you can do that? Right. Then I'm happy. Thank you.
Thank you, Stephane. Thank you everyone for joining us today. You can mingle, network. We are open until 9. Yeah, the doors will be closed. Have a nice night.
Thank you.
Thank you.